Welcome to Wings of Arrow. I'm here to help you guys with my best subject knowledge and ideas with you, so stay tuned to my channel. Hey guys, today my topic is Mohr circle. This tutorial will be highly effective for aeronautical, aerospace, mechanical and civil engineering students. First, I will generalize the thing. First, consider any element. From that particular element, I am focusing on a small precise element. On that element, it undergoing some force. See, as it given in the figure, along the x-axis, the tensile force is taking place, and along the y-axis, a compressive force is taking place, or we can say compressive stress is taking place, and along the surface and shear stress is undergoing. So for this particular surface, we can say if we have a shear stress is 0 for a particular plane, then the plane of the shear stress or normal stress can be maximum or a minimum, that is known as a principal plane. It can be sigma 1 and or sigma 2. Mostly the sigma 1 is denoted as a maximum principal stress and sigma 2 is denoted as a minimum principal stress, and the formula is displayed in your screen, equals to sigma x plus sigma y by 2 plus or minus root over sigma x minus sigma y by 2 whole square plus tau xy whole square. When we are considering a maximum, we will consider here as a positive, and when we are considering a minimum value, we will consider as a negative. Okay, so tau max, that is maximum shear stress, equals to plus and minus root over sigma x minus sigma y by 2 whole square plus tau xy whole square. In case of maximum shear stress, the tau xy will be 0, so you will get as sigma x minus sigma y by 2. And this is a formula, that is angle, which angle plane of axis it is creating a maximum shear stress. Then the purpose of Mohr circle, it is actually for a visual tool used to determine the stress at a given point in a relation to the angle of orientation of the stress element. As you can understand, there are 4 possible variations in Mohr circle depending on the positive directions are defined. So here comes, it can be a sigma 1, sigma 2 or sigma 1 or sigma 3. You can name anything, sigma 2 or sigma 3 plane, where the normal stress and the shear stress will act. So sigma s is also can be written as tau s or tau xy. So this explains that always the sigma 1 will be greater than sigma 2. And if you're dealing with the sigma 2 and sigma 3 plane, that means that there is two principal stresses would be sigma 2 and sigma 3. Now let's see the normal stress. This is a formula for normal stress. Sigma n equals to sigma 1 plus sigma 2 by 2 plus sigma 1 minus sigma 2 by 2 cos 2 theta. Now we can also write as capital C plus R cos omega. This omega is nothing but the 2 theta value. We are simplifying this above equation. What is C? C is the center of a Mohr circle and R is the radius of a Mohr circle. So what is C then? Here sigma 1 plus sigma 2 by 2 and R sigma 1 minus sigma 2 by 2, as it has been written over here. Now considering the when at what condition we will get a maximum and minimum normal stress. Now consider the theta value is 0. Now if we apply the theta value 0 over here, so what is cos 2 theta? We will get as 1. Now applying that here, we will get as sigma n equals to sigma 1 plus sigma 2 by 2 plus sigma 1 minus 1 sigma 1 minus sigma 2 by 2. If you simplify this equation, we get a sigma n equals to sigma 1. That is a maximum value. Sigma 1 is a maximum value. Now consider the theta value is 90. Substitute in the same formula, that is a general equation formula. We get as cos 2 theta equals to minus 1. Then if you substitute that here, we get as this equation simplify and we get as theta n sigma n equals to sigma 2, that is a minimum value. So from the above we can generalize that sigma n equals to sigma 1 at sigma equals to theta, that is a maximum value, and theta, when theta value is 90, we get as minimum value. Apart from that, there is some sign convention, that is when we get as normal stress is positive, that means the nature of a stress is compressive. When we get a negative value, we get, that means that having a nature of a tensile. That means when the sigma n is greater less than 0, when the sigma n is less than 0, it's a tensile, and when the sigma n, that is normal stress, is greater than 0, we get as a compressive strain. Then comes shear stress. Shear stress formula is sigma 1 minus sigma 2 by 2 sine 2 theta. Now similarly we have studied the radius formula, that is sigma 1 minus sigma 2 by 2 is a radius, so we have written here, that is tau s or sigma s, both are same, equals to r sine omega. So what it represents, that here how when is a minimum condition, when is a maximum condition. Mostly in competitive exam they ask this kind of question. So in shear stress, minimum will be when theta is 0, 90 degree or 180 degree, and maximum when the theta is plus or minus 45 degree or sigma 1 minus sigma 2 by 2. And from here if you need to find the diameter, that is 2r, so we can write that differential stress, that is diameter of a Mohr circle is sigma 1 minus sigma 2. This is a general formula when we are considering the tau xy is not equal to 0. So how we can remember this? See the formula, tau equals to sigma x minus sigma y by 2 sine 2 theta plus tau xy cos 2 theta. Now what is sigma n? Normal stress, minus sigma x plus sigma y by 2 equals to sigma x minus sigma y by 2 cos 2 theta minus tau xy sine 2 theta. Now here you see these are the common terms in both the shear stress and normal stress, but see their sine and cosine terms are getting exchanged. See here we have cos 2 theta, here the tau xy have a cos 2 theta, here we have a minus, here we have plus, and tau xy sine 2 theta, and here we have this value into sine 2 theta. This is a Mohr circle. This is how you have to draw the Mohr circle. Now comes some special states of stresses. There are around 4 important stresses, that is uniaxial, biaxial, pure stress, axial stress, and triaxial stress. So I will focus a generalized way with a Mohr circle, how they are denoted. What is meant by uniaxial stress? It can be having both the sigma 1 or sigma 2 if you are considering a 2D plane. So one of the axis will be non-zero and another one will be equal to 0. If you are considering a 3D plane or a 3D axis, then definitely one of the axis should not be 0 and other two should be 0. As you can see in the figure, that is having some value, positive or negative, it can be anything. So if it is having a positive value, that means it will give an positive impact. This is a positive quadrant and this is a negative quadrant. And similarly, if you want to find for the uniaxial tensile stress, you will have an negative here. So this is a summary of uniaxial tension and uniaxial compression stress. Next comes biaxial tension. Here one principal stress equals to 0 and other do not, that is the sigma 1 or sigma 3 has to be 0 and other two may be positive or negative. As you can see that one of the thing has to be among the three, one of the thing has to be 0. So this one is the both the sigma 1 or 2 or whatever you consider are in tension. This is in compression, and here one of the thing, this side means tension and other side is a compression. Here comes axial stress. In axial stress, it expresses that if among the three axes, the any two will be equal to each other and another will be non-equal to another. That means it is an axial stress. Next comes pure shear. So how the pure shear we can denote? Both having the, when both the stresses are non-zero. They should not be non-zero, but they have an equal magnitude but opposite in nature. Now see, in that kind of cases, the Mohr circle will be, the center will be on the origin and both will be have equally shared in the negative and the positive. These are all the stages of stresses in various conditions. Triaxial stress. In triaxial stress, we have all the principal stresses are non-zero. They all will be having some random values. It can be a positive or negative. It can be distinguished by like this as shown in your screen. Our overall prescription here, the difference between the maximum and the minimum value of principal stress are sigma 1 minus sigma 2, which should be always be positive. From there we can derive that the twice of the radius, that means the diameter of the largest Mohr circle is nothing but, or the sigma 1 minus sigma 2 by 2 is twice the maximum shear stress, and shear stress is maximum at the angle 45 degree plus and minus 45 degree. Thank you for watching. If you have further inquiry, drop down to the mail wingsofarrow@gmail.com. Thank you for watching and don't forget to subscribe to my channel for more updates. Take care, stay blessed.